What do you call an alligator in a vest? An investigator. Haha. All right. So this is Unit 3, Lesson 3, entitled Two-Way Tables. Your I can statement is to create a two-way table to fit an appropriate situation and be able to use that table to find relative frequencies of two variables and any possible association between those two variables. All right, we're going to first go over the vocabulary, the words that I underlined, and then we're going to do two example problems. So we've got two of them here, okay? The vocabulary words, relative frequency. It's a ratio of the number of times an event occurs to the total number of events. So if there's a total of, let's say, 10 crashes, car crashes, and 5 of them involve red cars, then that means 50% of the car crashes involved red cars. That's all a ratio or a relative frequency is. We take the number of times an event occurred, in this case a crash with a red car, and put that over the total number of events, in this case crashes. The association is the relationship between two variables, and we've already talked about positive association, negative association, or no association, but we've only looked at those when they're involved with a scatter plot. Now we're going to have to use a two-way table to determine if there's association between two variables. Okay, so the first thing we want to do is learn how to fill out these two-way tables. They're a little weird at first, but once you do a few, not a big deal. Okay, let's read this. A poll of 120 students, town residents, excuse me. I don't know why I'm reading crazy here. A poll of 120 town residents found that 40% own a bike. Of those who own a bike, 75% shop at the town's farmer's market. Of those who do not own a bike, 25% shop at the town's farmer's market. So there's a lot of information there, and we're going to break it down in this table. We see here where it says total and right here where it says total. At that intersection, if you follow that row and down that column, that's where we want to put the total number of people. In this case, the total population is 120. Notice we're comparing two different variables. The first variable is bike ownership, whether or not someone owns a bike, right over here. The second variable is whether or not people shop at a farmer's market. So instead of a scatter plot where we'd have something on an x-axis and a y-axis, we're putting it into a table, okay? So once you fill out the total here at the intersection, the total amount of people, sorry, there's an announcement right now. I'll wait just a second. You can begin using the information they give you to fill out the rest of the table. So it says 40% own a bike. 40% of the total people own a bike. And so that total will go right here. Because right now we're not interested in how many people who own a bike also shop at a farmer's market. We're interested in the total number of people who own a bike. So we have to figure out what's 40% of 120. To do that, we turn 40% into a decimal and multiply it by 120. So when we do the math on that, we get 48. So 48 people out of the population own a bike. Of those who own a bike, 75% shop at the town's farmer's market. So that number will go here because two things. They have to own a bike and they shop at the farmer's market. So that's where this box intersects. It intersects the farmer's market and the bike line here. See that? So we would figure out what's 75% of the amount of people who own a bike, in this case 48. So 75% of 48 would be found the same way. Convert to a decimal and multiply by 48. And I'll erase my work over here and we'll do it. Okay? So let's do the math real quick. 75 hundredths times 48. When we do the math, we get 40, 24, 6, 28, so 33, something like this. 0, 10, 6. So it looks like 36. And I had to use my decimal trick here. So 36 is 75% of 48. And I could have done that in my head because 25% of 48 is 12, and 75% is 3 25%. But I wanted to do it on the board here so you could see it's just a simple matter of multiplication. So let me erase these X's here. We know that number now. So now we just kind of read on. So we filled out the 75% of bike owners shop at the town's farmer's market. Of those who do not own a bike, 25% shop at the town's farmer's market. Okay, so that would be a no bike shop at the town's farmer's market. So that number would go here. We need this number, though, to figure that out. And the way we can figure that out is we know 48 people own a bike out of 120. So that would mean that if we subtract the amount of people who own a bike from the total number of people, we'll figure out how many people don't own a bike. So we'll do that subtraction really quick. So 72 people don't own a bike. Okay? So now we can figure out what 25% of this number is and put it here. So we need to figure out 25% of 72. Notice I got 72 through simple subtraction. So 25% shop at the town's farmer's market. If they don't own a bike, the number is going to go here. We're going to figure out what 25% of 72 is real quick. It looks like it's 18. So that would mean that 18 people don't own a bike, no bike, but they still shop at the farmer's market. Now we can fill in the rest of the table just from the information we have. So we don't have to worry about any other stuff from the problem. We can just use the information in the table to finish it out. If the total number of people who owns bikes is 48 and 36 shop at the farmer's market, then that means there must be 12 people who own bikes and don't shop at the farmer's market, because 36 plus 12 is 48. And this right here needs to be the total of these two numbers. Similarly, if 18 people don't own a bike and shop at the farmer's market, and there's 72 total people, we can use subtraction to figure out how many people don't own a bike and do not shop at the farmer's market. So we do the subtraction here, and we get 54. Now we can just fill out our totals. So what's 36 plus 18? And our total will go here. So 36 and 18 would be 14, so 54 total farmer market people. And 12 and 54 would be 6 and 6, or 66. So that's all there is to filling out a two-way table. And once you start with a total and start plugging in the numbers that they give you, 40% of or 75% of, the rest is easy. All right, one more quick example here. In this particular problem, we're going to actually find association. It's a different table, and we're going to use the data in a table already filled out to answer these questions. It says, find the relative frequency of having to do chores. Well, it looks like the total number of people that have to do chores is 20, so that's the number of events. But in the denominator, we need to put the total number of possibilities. There's 100 right here, 100 total people. So 20 divided by 100 is 20%, or 20 hundredths. So the relative frequency of having to do chores is 20%. I took the number of kids who total that do chores, and I divided it by the total number of people. Now it says, find the relative frequency of having to do chores among those who have a curfew. Okay, let's take a look here. Of having to do chores among those who have a curfew. So we would want to know total how many people have a curfew, and that number is right here, 32, because you have all these columns right here that add up to 32. So that would go in the denominator because it's a total number of possibilities. And having to do chores, it looks like 16 out of those 32 kids who have a curfew do chores. This is a 50%, or 1/2 relative frequency. Now here's a question. Is the general population or students who have a curfew more likely to do chores? In other words, 20% of the general population do chores, but 50% of kids who have a curfew do chores. Who's more likely to do chores? The general population or the kids with the curfew? And you're right. The students with the curfew are more likely to do chores because they have a relative frequency of 50% versus the 20% of the total population. So is there an association between having a curfew and having to do chores? We could say, yes, there's a positive association. And the reason we can say yes is because the 50% is greater than the 20%. In other words, if you have a curfew, you're more likely to have to do chores than if you're just someone in the general population. All right, guys, I'm going to leave you with that right after I give you the number clue. Number clue, this is the last one. It is between 51 and 59, and with that, you should be able to get the number. All right, guys, these two-way tables can be a challenge at first, but you just got to buckle down and try and do them. You'll get it.